there's a polarized light. These arrows I have to draw. Yeah. Linearly polarized light it is. I'll pass through a polarizer. There's a diagrammatic representation. Don't think that polarizer will be like this. I am making clear. This is just a diagrammatic representation. Polarizer. And there's a path axis. Path axis is y-axis and it's a linearly polarized, and how E bar vector is vibrating along y-axis. So therefore what we get, anything will happen. What this polarizer will do, I sent a linearly polarized light. So anything this polarizer will do. So this is a path axis. Nothing will happen. The light what happened, the linearly polarized, and again we'll get the linearly polarized light. What was the intensity? Say what you say I, the same intensity. No change in that one. But sir, you only side if you, when an unpolarized light passes through and a polarizer, intensity will become off. This is already linearly polarized, and what this polarizer will permit the light to pass along y-axis, and this is already linearly polarized. And the E bar and the path axis is y-axis, and this is vertically polarized. So therefore it just permit. So no change in intensity. Now slightly let me rotate this. If I rotate this one, if I rotate, so let me call this as I naught. Let it be I naught. If I rotate this path axis, I need some diagrams. What will happen to the light? It will get polarized. So, so what is the path axis? This one, no? These arrows are. The red, this is a path axis. This is the angle theta. This is a linearly polarized light. The intensity is how much it is? I naught. What is the intensity? This will be I. So according to malus law, so what is telling the intensity is equal to I naught cos square theta. So what it does, you just resolve that amplitude, no? So nothing bigger. What is intensity? Directly proportional to amplitude. So if the amplitude is A cos theta, A sin theta. A sin theta will be blocked. A cos theta will be permitted. So I'll square it. That's what I naught cos theta. What is I naught? I naught is the intensity of linearly polarized light, not like unpolarized light here. So what is this? This is also linearly polarized, but what is intensity further got decreased here? So I'll make theta sir 90. Okay, no light will come. So we can now easily understand the polarizing effect by passing linearly polarized light to a polarized where the path axis makes some angle with respect to the plane of vibration. So this was the E bar vector was along y-axis, the path axis like this. So as I rotate this, so what will happen for me? The intensity first was maximum, then decreases, becomes 0, then again increases, becomes maximum, then again decreases, and finally becomes like a becomes maximum, then decreases, again becomes maximum. Cos square function, I think how you know the variation of cos square function. So can we have a graph of this, the variation of intensity with theta? Put theta 0, cos square theta's negative of cycles should not come. This is I naught. This is theta. This is 0. What can be this? 90 pi by 2 pi 3 pi by 2 2 pi. Will I agree this? This is the thing, that one. So the intensity of the light. Now I can clearly see that one because the intensity is varying, and somewhere it becomes 0. When the path axis perpendicular, when path axis along z-axis, no, I don't see any light. Then I don't see any light means how it will be? It'll be like a pitch dark. So light is coming. Okay, I'm able to see that. The variation of intensity I can notice here. What is I now? Intensity of light after passing through polarized. So it's a linearly polarized. So what you call this also linearly polarized here. If you pass unpolarized light, if you pass unpolarized light and you rotate polarized, anything will happen. Anybody wants to answer? Here is what I'm trying to.
Not by 2.
Will remain fixed? No, this will be unpolarized light. As I rotate, for all the positions you get I naught by 2 only, the intensity will be fixed here. So as you rotate theta, you get that one. So now let me write that comment here. When polarized is rotated, the light gets linearly polarized, and the intensity of light will be constant. This is the idea. So to really notice that effect of polarization, no, either pass linearly polarized light or go for two polarites. If you take two polarites, I think it'll be still more better. Okay, let me start now. Here's what, these are the types of numericals, what you can get it now. Okay, let's begin like this. So this is the, we'll draw that arrows. Okay, this is the path axis. Path axis is along y-axis. For our coordinate system, we can pick up y, x. Okay, this one. So there's a path axis. There's a polarized one, P1 you write it. Now let me align another polarized. There's a second polaroid P1 and P2. This second one, though it's a polaroid, I'll give a name, analyzer. What is the polarizer? Say quartz crystal made up of. This is also quartz crystal only. The second polaroid will give a better name called as analyzer, because I can easily analyze what will happen to intensity now. So this is the angle theta with y-axis. So this is the P2 I'll call, or some books they say P and A. So let me call P2. After this, okay, this one, I'll give some. What will, there's unpolarized light. Anything will happen after pass axis is y-axis. We'll get vertically polarized light. No, what will happen? No, the light will be like this. If you want, you can show the length of arrow a little bit decreasing to show that the intensity is decreasing. Okay, now there's an unpolarized light, linearly polarized light. There's also linearly polarized light. The intensity here, let it be I naught. How much here intensity? I naught by 2. What about intensity of this? I is equal to I naught. So like I naught by 2 cos square theta. Okay, according to Malus law, if a linearly polarized light passes through a polarizer, then the intensity is given by intensity of linearly polarized light into cos square theta. What is theta? Angle between the polarizer and the this y direction. This is the theta I'm putting. So what is this? This one, pass axis of P2, pass axis of P1. So slightly what happened? The polarizer P2 makes an angle theta. By rotating this S, now we have a very different things will come. If theta theta 0, let's see that what I will be. If you want, I'll write I2, the intensity I2. What will be the intensity? If you rotate, so let's do one thing. I'll keep this pass. Okay, first we'll do one thing. This is fixed here. This will rotate. Theta 0, what is the intensity will be? I naught by 2. No, theta equal to pi by 2. Anything will happen to intensity? Put theta 90, it will become 0. Pi I naught by 2. 3 pi by 2. 0. 2 pi. Got the idea, no? This one, this will be the intensity of analyzer. What is I naught by 2? There's the intensity of this is what is this quantity? Intensity of analyzer. The person, what happened, will see clearly no light, complete darkness you will see for theta 90. So like this, the intensity will vary harmonically. That definitely can say, no, you can say yes, the light is analyzed here. So now this polarization, what do it will support? Wave nature or particle nature? The wave nature, no, showing that E bar and B bar. No, the polarization, what do it will support? Basically, it will support the wave nature of light. So I'll bring one more polarizer here. Then that polarizer will make angle some theta 2. Okay, then again you write Malus law. We can write continuously. So as I rotate this P2, what happened? I can say at one position when P1, P2, pass axis of P1, P2 are perpendicular, we get 0 light. So here what happened? Pass axis of P1, P2 are perpendicular. Theta is what? Angle made by pass axis with pass axis of P1. How is this? This will be rotated along, this will be fixed along y axis. No, sir, I will keep this fixed, I'll rotate it. Anything will happen here. we can do like that also, no? I'll keep this fixed along y-axis. I'll rotate this one. Again, how that polarizer light will come here, that matters. Okay, the analyzer is nothing but a polarizer. The second polaroid is called as analyzer. Okay, now I think when college reopens, no, I'll bring that polarizers. I do have that one. So what is the meaning of this? It is very simple. Suppose you have your physics teacher. Let me draw myself. Okay, this is your physics teacher. So these are so I'll bring two polarizers. If you have two polarizers, no, if you start looking at your physics teacher, so it will be there will be light blue in color. No? Should be visible. Yeah. Very simple way. I because all in class I would have shown. No, so let me. So what is the meaning of sorry intensity, sir? We are not understanding what do you mean by intensity. All I'll through diagrams I'll explain it. These are the two polarizers. No, let me clone myself. This is one. No, you are able to see physics teacher. So you are going to bring the polarizer and analyzer. So let me indicate their pass axis. Okay, this will be. I have to indicate pass axis, no? I'll bring pass axis later on. So you are going to keep one more. Yeah. No. So you're kept like this. What actually you're seeing, you're able to see your physics teacher. The reason for that, the pass axis of both are parallel. I have simplest. So I'll indicate that path axis here, or we'll show that arrow there. That one. So now you're going to bring two polarides in such a way that if their path axes are perpendicular, the path axis of this one is like this, of this one is in this direction. Are you trying to notice now? So you see complete dark. You don't see my this part of my face. Okay, you should not see, no? Yeah. You can, if you purchase polarides, no, little bit they'll be costlier. Or if you have some old calculator that I think the only old calculator, if you have that 200 rupees available, no, you there what you can see, the display, you remove that LCD display, below that glass will be there, below that there'll be like a polarized sheet, you take it out, that one, it'll be like usually some 2 centimeter and 1 centimeter width and 2 centimeter long. Cut that into 3-4 parts. Take 2 parts and start rotating. No, you can notice like this. So there's a polarized one. When you keep the two polarides with their path axis same, so if a theta is 0, then what happens? We'll get the intensity. No, of course you don't see clearly because some light is blocked. Am I right? When you make the path axis perpendicular, you can't see this part of my face. Able to analyze this word. So look at the polarized one, P1, P2. Both are perpendicular to each other. There's a general. If you have two polarides, no, you can do experiment. You can try to see somebody's face. No, this part of face will be blocked here. If you move this further towards left, no, then more dark region will come. The reason for that, path axes are perpendicular. Here path axes are parallel. As you are able to see, but less intensity. You can see now clearly. Your face feature is available very clearly. Okay, smiling face, everything. What about here? We can't say anything because this part of his face will be blocked here. If you have polarides, no, we can do experiment. We can see clearly this one. So what is this one? Two polarides. Crossed normally. Crossed normally means their path axes are perpendicular. Crossed normally or path axes are perpendicular. Here, two polarides are the cross axis path axes are oriented parallel, right? Path axis of polarides oriented parallel. We are able to see with less intensity. Some light will be blocked here. So how much, like suppose say I naught will come. This will block I naught by 2. Will it be I naught by 4? No, I naught by 2 only. Already I told you. Linearly polarized light, when it passes through a polarizer, what will happen? We'll get I naught by 2 only. Unpolarized light, when it passes through polarizer, will become I naught by 2. When you bring two polarides where theta is the angle between P1 and P2, pass X P1 P2, then we'll get this equation. Malus law, very, very important. So what is this? What is I naught by 2? Intensity of linearly polarized light. And what is theta? angle between polarizer and analyzer. Okay, fine. I think everyone is able to understand. So there's a basic malus law, the description. If we have three polarizers, let me give that diagram also. We do have plenty of questions of this kind. First, we'll draw polarizer. Not vertical. First, let me draw a vertical line. Blue color. Okay, this is there's a polarizer. Anyway, it will this one. So we'll start with this one here. This is a unpolarized light of intensity, say I naught. There's a polarizer. This I'll call P1, this P2. The intensity here, how much will become? I naught by 2. Now we'll call this intensity as I1. This is I2. We'll write expression for that. So this angle, let it be theta 1. There's an angle, there's a vertical, should be parallel to that. These two lines parallel. What is theta 1? Angle made by polarizer P1 with the polarizer P. Theta 2 is the angle made by the polarizer P2 with path axis of polarizer P1. So this dotted line, what is this? Path axis of P1. What is I1? Equation for I1? Equation for I1 should be equal to I naught by 2 cos square theta 1. What about I2? I2 should be is equal to I1 by 2, or shall I write only I1? Only I1. I1 equal to cos square theta 2. Substitute value of I1. I naught by 2 cos square theta 1. Able to understand. So what are theta 1, theta 2 will define? Theta 1 is angle made by path axis with y-axis. This is a y-axis. What is theta 2? Angle made by path axis of polarized P1. Of polarized P2 with path axis of P1. Okay, got the idea now. So let there be n number of polarites. We can keep on write malus law. So this is unpolarized light. This what we should call linearly polarized. This is also linearly polarized. This is also linearly polarized. Okay, this is about the basic, the malus law. So there's one method of how to produce the polarization, means how to change the intensity of light. I can use this one. We use this exclusively in the photography. This is the something very important. You are a photographer and you don't know polarization, you are not photographer modern day. I'll show in the end some diagrams, how exclusively it is needed. Okay, this is about the, so like this, how to polarize a light using polarizing crystals. This is one thing. I can also polarize by reflection. There's a malus law. So next one, what we have,